Another type of bias that we deal with is information bias. This is bias arising from systematic measurement error. It's a bias in the way that we classify our information. So we're collecting the information inappropriately or something like that. It's not about who is being studied. It's about what we're actually doing as we collect. So one of those issues is measurement bias. We could have an insensitive measurement tool where we're measuring height, but it doesn't whatever we're doing doesn't do it every inch. It does it every 3 inches or something like that. Or you just have a tool that is not able to get to the level of resolution you need for what you're really interested in. So there's some sort of bias coming from the instrument that you're using. It's miscalibrated. It's not working properly. Something like that, where you're actually measuring things, you're getting the same answer probably time after time, and it's always the wrong answer. Another problem we have in collecting the information is something called terminal digit preference. This is a chart that shows people's height in centimeters, both self-reported and measured. And if you look at what's measured, it makes sense that the last digit should pretty much be the same in everybody. You have a normal distribution, especially using something like centimeters, you're going to get a lot of people that where it ends in 0, 1, 2, 3, 4, that sort of thing. If you ask people though about their height and what they report, you don't see that same sort of balanced distribution. You see a lot of people round it off to the 0. Or there's spikes at the 5 or the 2 and the 8. So they generally don't say that they're, something that ends in 1, they were just going to round it down to 0, or they're going to round it up to 2. And so this winds up happening a lot where you have people that have to observe a scale and round things off. Think about a blood pressure cuff. If it's not a digital one, if somebody is using the manual process and they're looking at the gauge, quite often they round it off to the nearest 5. So you're much more likely to see a blood pressure of 120 over 80, even though the person's blood pressure was actually 119 over 79, because it just gets rounded off and people tend to gravitate towards certain numbers. Another big one that we talk about quite a bit is recall bias. And recall bias is going to be present in any study where people are asked to remember past exposures or disease. So if we're asking about your lifetime smoking, you may not remember exactly how much you smoked 20 years ago. You may have trouble saying exactly when the illness started or something like that. So it's just the problem of people trying to remember things. And the further back you go in time, the more difficult it's going to be to remember things correctly. So you can design your approach to help people maximize their recall. You could ask more specific questions that get you more specific answers rather than saying, "Tell me about your smoking history." You could ask a lot of detailed questions. Okay, during your time in high school, did you smoke? And if so, those sort of questions that help people remember what you're really interested in. One problem we do see is there can be differential misclassification as well, especially when you're looking at a case control study, where people with the disease could remember the exposures differently than those without. If I'm asking you about exposures that were potentially related to your cancer, you may be thinking about those things more, and you may be, because of that, you were able to jog your memory a bit more and have a better recall of things that you've been exposed to over the last 20 years or something. Another issue we see in getting accurate information is what's called an unacceptability or a desirability bias. People tend to answer questions in a way that they think will be viewed favorably by others. So if somebody asks you, you go to your dentist and they ask you how often you flossed, your tendency is to give them the answer that they want to hear rather than the truth. And that can be a challenge in collecting information, especially on a very sensitive subject. Um, Sometimes it's about acting a certain way with a group. If you ask a high school kid about how many sexual partners they have, more is probably seen as better, and so they may lie and say a greater number than they actually had. But say you're doing a study of alcohol consumption, and you would expect different groups to report that in different ways because of what's seen as acceptable or favorable by their community. Members of a religious community that strongly believe in temperance and not drinking would probably underreport their values or deny drinking at all. They may drink, they just don't want to say that to somebody because that's not the acceptable answer. Whereas if your ability to drink a lot was seen as a measure of virility and made you the important person in your social group, you're probably going to overreport your values and claim that you actually drink more than you really do. So you're not getting the same information from those different groups, and that's something you definitely have to keep in mind as you're analyzing your data. So sometimes the subjects are trying to give you an answer that they perceive to be the appropriate one. Other times it could be the interviewer or the design of the questionnaire that results in people giving an answer that you want. So they have a partiality toward a particular preconceived response based on the way that you're reading the questions. The interviewer can also lead a person to a specific answer. So think about trying to do a survey where you're looking at injection drug use. And if I ask the question, have you ever injected something not prescribed by a doctor? That's very neutral. It's getting at the idea of injecting something into your body that is not a prescription medication. If I said, have you ever injected an illegal drug? Well, first of all, it's going to be a different question because it's not all substances like vitamins and things like that. But the word illegal in there makes it seem like it's something bad and something you shouldn't do. So people would be more likely to say, well, no, I haven't, because they don't want to admit to some sort of illegal activity. Or you could have very kind of pointed questions that tell people what you're looking for and have some judgment in them, like, you don't shoot up drugs, do you? Or are you a junkie? Those type of questions are still trying to get at injection drug use, but they are completely inappropriate ways to ask those questions, because you're going to get people saying no, because even if they do use injection drugs, if you phrase questions like that, there's already some judgment coming from the question, and the people are going to be less likely to give you an honest answer as a result. Now, the Hawthorne effect or the observer effect is the basic idea that people can change their behavior just because their study subjects are being observed. At a Western Electric plant called the Hawthorne Works in Cicero, Illinois, outside Chicago, they did a number of different studies and approaches to try and improve worker productivity. So a lot of the stuff that you hear about the Hawthorne effect really was kind of a more of an anecdote than any true analysis that gave this answer. But one of the things that they proposed was that lighting changes would result in increased productivity. And so they, over a several year period, they played around with different types of lighting. And anytime they changed the lighting, they seemed to find an increased productivity. It wasn't that the lighting made a difference. It's the fact that they proposed that it was people just being observed change their behaviors. And so if you look at the actual stuff of the Hawthorne effect and all the studies, there's argument about whether it was really identified there, and that's the explanation for the difference in productivity. But what we're talking about is people changing their behaviors because they're being observed, which is a very possible thing to happen. I've seen it myself going out for outbreak investigations into a restaurant kitchen. As soon as you get there, as soon as the restaurant inspector shows up, even for a regular inspection, everybody washes their hands. They pay close attention to what they're doing, and they try to do everything right. And then you hang out in the back for 20 minutes or so, and they start to go back to their normal routine behaviors. And so depending on how you set things up, what you really could be measuring is the fact that people are changing their behaviors to do something that they see as the appropriate way to behave or act, or the way they were trained or something like that. But it's the idea that simply being observed can result in a behavior change, and that may be the explanation for the difference that you're seeing and not the intervention itself.